Hello everyone, welcome to Keep Learning at the rate Be Creative. So today's problem is a regional mathematical Olympiad problem from 2015. So let's begin with the problem. Let ABC be a right angle triangle with angle B equals to 90 degree. Let BD be the altitude from B to AC and draw DE perpendicular to AB, DF perpendicular to BC. Let P, Q, R and S be respectively are the incenters of the triangle DFC, DBF, DEB and DAE. Suppose S, R, Q are collinear. Prove that P, Q, R and D lie on a circle. So the main important thing here is to first draw the diagram correctly. So we have been given first a right angle triangle ABC. So we have drawn this triangle ABC right angled at B. From B we have to draw an altitude BD. So we have drawn the altitude. Then from D we have to again draw the altitude on AB. From D again we have to draw an altitude DF on BC. And now we have to mark their incenters. Here we have the P as the incenter of triangle FDC. Similarly, we have the Q as the incenter of the triangle DBF. Then we have R as the incenter of triangle DEB. And finally, S as the incenter of AED, or we can say DEA. Now, we have SRQ as collinear. That means a straight line passes through these 3 points. We need to prove that PQR D lie on a circle. So this is what we need to prove, and if we are able to prove that these points are concyclic, that is if we are able to prove that this form a cyclic quadrilateral, then this will be lying on these 4 points will be lying on the circle. So let's begin with the solution. Now we have already drawn the diagram correctly. So for solving this, let me just rotate this diagram. Now before moving to the solution, if you remember a concept, or let me just remind you that if we have a right angle triangle and if we draw an altitude AD on the hypotenuse, then we will have 2 more right angle triangles. Now in these 2 small right angle triangles, if you take the incenter of this triangle ADB and the incenter of triangle ADC, that is Q, and if you join these 2 incenters P and Q, then it will intersect the other 2 sides at point M and N if you want. So here the angle AMB comes out to be 45 degree. So if you remember this concept, it will be very easy for us to solve this question. Let me tell you how. So here we have this as a triangle, and if you remember that we have drawn BD as altitude, so we have BDA as a right angle triangle, also BDC as a right angle triangle. Now I can say that QRS are collinear, which was given to us, and I will join P and Q also. Now to move to the solution, I will use the concept which I have just now told you. So here you can see, if I take out triangle BDA as outside this figure, this is a right angle triangle and BA is the hypotenuse. So I have drawn DE altitude on this BA. By this I am getting 2 small right angle triangle here, DEA and DEB, and S and R are the incenters of these 2 triangles. So if I further join this, it will intersect DA side at X. Similarly, I can take out triangle BDC out, and here BC will be the hypotenuse on which I have drawn DF as the altitude. So we have again 2 small right angle triangle DFB and DFC, and since P and Q are the incenter, and if I connect them, it will intersect CD at Y. Now if you remember the concept, we have this angle as 45 degree using the concept which I have just now told you. So if you mark this in the above diagram, we have this angle as 45 degree. Now also we will be having angle QYD as 45 degree with the help of the previous concept which I have told you. So we can mark this as in this diagram QYD as 45 degree. Now we can see that in triangle YQX, you have this angle is 45 degree and this angle is 45 degree. So by applying angle sum property, we have the value of angle XQY, this angle XQY as 90 degree. By the angle sum property, since these two angles are 45, sum up to 90 degree, and since the sum of the complete angles, three angles of this triangle comes out to be 180 degree, so angle Q has to be 90 degree. Now we have angle YQX as 90 degree. Now we can say that if we consider angle BCD as 2 alpha, and let us chase some more angle, so we can write angle CAB as 90 minus 2 alpha, as triangle ABC was a right angle triangle, so these two angles will be complementary angles. Now we can mark angle FDC as 90 minus alpha. Again we have CFD as a right angle triangle, so these two angles again will be complementary. Similarly, we can say about triangle DEA, we have angle EDA as 2 alpha. Now angle BDA is 90 degrees, so we can mark angle BDE as 90 minus 2 alpha. As this angle is 2 alpha and this complete angle was 90, so this small angle comes out to be 90 minus 2 alpha. Similarly, we can mark the angle FDB as 2 alpha. As this complete angle was 90 degree and this small angle we have already marked as 90 minus 2 alpha. So remaining this angle comes out to be 2 alpha. Now if you see that DR and DP are the angle bisectors, so further we can mark angle RDB as 45 minus alpha and angle PDF as 45 minus alpha, as they were the bisector of the respective angles. Now if we take out the value of angle PDR, so here it will be equals to PDF plus FTB plus BDR. So if you substitute the value, the final value comes out to be as PDR is equals to 90 degree. So we have PDR angle as 90 degree. If this angle is 90 degree, we can say that angle PDR plus angle PQR as 90 plus 90, that comes out to be 180 degree. Since the sum of these two angles comes out to be 180 degree, we can say PDRQ are cyclic. So we have PQRD lie on a circle. I hope you liked the video. So thanks for watching, and if you want to know how did we get the previous concept which we applied in this question, you can click on the given link.